All right, so many faces, so many familiar faces, but also a lot of new faces. For those of you who don't know me, my name is Jason Hand. I'm one of the organizers here with DevOps Days. Excited to be here. This is our fifth one. As you can see, we're in a brand new venue for those of you who have been to DevOps Days before. In fact, how many of you have been to, well, who was here last year? Wow, okay. Keep your hands up. Who was here the year before that? Okay, and the year before that? And the year before that. Who was here for our very first one? There's a couple of people. Here, let's do this. You want to take care of this? Hold your hands back up. Who's been here all 5 years? Let's get a, pass one right here. So tell us, why do you keep coming back? What is it about DevOps Days that has you coming back to our fifth one? Just talk right into the box.
It's been pretty good, just learning new technologies that have been growing. From the first one, I remember some Puppet being shown. Just continue going. I don't know. Awesome.
Who else has been here for 5 years? I want to hear, why do you keep coming back to these things? Why are these things good? What is it about a DevOps Days that keeps you coming back?
Like this. To be honest, I feel like I'm just hanging out at the bar the whole day. It's pretty nice. Get to meet old friends, see new faces, and it's a lot of fun. So.
Awesome. Anybody else? We got one more we can hear from? Any other brave people? No? Okay. Well, let's move forward. We're running just a little bit behind, but not too bad, and I think we can probably make it up. I'm just going to go through some housekeeping stuff, just the things that you probably maybe already know, but let's make sure we're all on the same page here. This is our Wi-Fi. If you haven't already gotten connected to our Wi-Fi, the SSID is just DevOps Days Rockies. The password is DevOps Days 2019. That's all lowercase. For those of us that are organizing, you'll see we all have the red on our badges as well as the volunteers. So if you have any questions about anything at all, just come grab one of us. But we've also got some other color coding here that I think you ought to know about. Anyone with a blue lanyard is going to be one of our speakers. So keep an eye out for them. And then the people with the black, that's all you, our participants. Thank you so much for coming and participating in this event. We like to call you participants rather than attendees because this is a community event, and this is all really about you and about having conversations amongst one another. So we feel that you're more of a participant than just simply an attendee. And then, of course, our sponsors, which we couldn't do any of if it wasn't for them. So anyone with a white badge is someone who's helped us put on this event. So thank you to all of our sponsors. Also, for those of you who don't know, we've got a meetup group. Denver DevOps Meetup was kind of the origin of DevOps Days, and that's still going strong. We have meetups all the time. We've also got a Slack channel that we introduced, I think, last year for the first time during DevOps Days. So if you're familiar with Slack and you use Slack and you want to join another Slack group, we've got that going. And if you just go into the channel DevOps Days 2019, that's where the conversations about today's event and tomorrow, of course, will take place. I've already mentioned our sponsors. Thank you so much for everybody who's helped put on this event, not only this year, but previous years. There's a lot of companies who have been here since the very beginning, and so we want to thank all of them for their continued support and coming back every year and making sure that we can put on an awesome event. Specifically, we want to call out Oracle. Thank you so much for providing our coffee. We know coffee is a super big deal to y'all. We heard that, I think, in year 1 or 2 that we ran out of coffee, and that was really, really bad. So thank you, Oracle, for making sure everyone's caffeinated. Our code of conduct, we always go over this. It's super important. We want to make sure that everyone feels very welcome. This is a very inclusive group. We are a community event. We want to make sure that everyone feels like they can be heard, that they can be part of this event. And some of the things, one of the things that we like to say, I'm over at Microsoft now, so of course we're a very diverse, large company, but we always say that diversity is reality, and inclusion, inclusion is sort of our choice. And so we want to make sure that we're being really smart about how we welcome people into our community and making sure that they feel safe and part of it. So if you haven't already read the code of conduct, make sure you check that out. It's on DevOpsDays.org. You can go to the Denver one and check that out. Some of you have already been asking as far as bathrooms, bathrooms go. There's a couple down here on this floor over to my left. You can see back in that little hallway. And right above them, up in the mezzanine level, there's another set over there. And then, of course, over across the way in the Ironworks, there's also bathrooms upstairs and downstairs. Upstairs in the mezzanine room, we'd like to thank our friends, our pals over at Vicarious for providing the on-call room. If you need a place to just go and deal with whatever may be coming up as far as work goes, you got some calls you need to take, just keep the volume down. We want to make sure that's a nice quiet space for those of you that need to get some work done. So thank you, Vicarious, for putting that up. Also, over in the Ironworks room, up on the top level, we've got a little place where you can get some professional headshots. So if you need some new headshots made, that's going to be a great opportunity for you to go over there and get that done. So let's go through the program real quick. I just want to give you a real fast run through of what we're going to be talking about today, what we're going to be doing. We're going to kick things off with J. Paul Reed. He's been here before a few times. In fact, he's been here every single year, I want to say, right? Yeah, I think he's been here every year. Not speaking, of course. So J. Paul is going to kick things off for us with his keynote. Then we're going to move on to Kim, who's going to talk about going from 0 to SRE from 9:30 to 10 approximately. Then we've got Abby and Jared. They're going to come up and talk about a journey to become more agile, a weed map story. Then we'll do just a real quick bio break, just a break to get some food, use the bathroom, whatever you need to do, about 10 minutes or so. And then we'll come back. And then something else I want to make sure everybody's aware of, both during the breaks, during lunch, during whenever you have time, we're doing our vendor passports again, and we'll be giving away some really, really awesome stuff at the end of Tuesday. For those of you who aren't familiar with the vendor passports, there should have been a little card, little sheet that you picked up when you checked in. All you got to do is just go say hi to all the vendors. They'll mark off your card. Then you turn that card into us, and suddenly you're in the drawing for some really sweet stuff. So make sure you go say hi to all of our vendors, all of our sponsors for helping us put this together. Then we'll come back and we'll let Sarah kind of take it from there as far as how to DevOps when it does not want to. So that should be a really interesting talk. And then from there, we'll kind of round things up in terms of our big talks. We've got James talking about product management and DevOps together at last and kicking butt. And then from there, we'll move on to our open spaces and things like that. But we'll also going to do lunch before all of that. And what we've done this year, similar to before, we've got some food trucks, and we've got several different options. We've even got some vegetarian and vegan options. So the food trucks will be here and be set up once we're ready to do lunch. After lunch, we'll come back and we'll do the Ignites. For those of you who aren't familiar with Ignites, they're 5 minutes, rapid fire. The slides automatically advance for the speakers, so they really have to sort of stay on top of their deck and get that content going. So Ignites are always fun. And then we'll come and start our open spaces, and we'll get everything set up in terms of how we're going to figure out what topics we're going to talk about, where exactly in this facility we're going to put our open spaces. If you remember over at the Exto, it was a little bit of a challenge to do open spaces. Last year we thought we'd get clever and put them outside in a tent, and then all of a sudden Mother Nature decided to provide us with some 90-mile-an-hour winds, which was not great. But we're going to do what we can to do open spaces in another way, and hopefully those turn out really good. I know that's something that everybody, well, maybe not everybody, but a lot of people always look forward to. The open spaces is where we get to talk to each other. You get to talk to your peers and hammer out questions and problems that you're all going through. And then last tonight, as always, we've got our social event, which is actually going to take place here. We've got a band coming. The Boulder Blues Mafia is going to be playing for us. And yeah, it should be fun. So we'll have food and beverages and all that kind of stuff. And if you can hang out, we'd love for you to do that. We'd like to thank our friends over at Mesosphere for helping sponsor that part of the event as well. And with that, that's my last slide for this morning. So we'll go ahead and get J. Paul up here and get plugged in. Yeah, come on over and grab some seats. Like we said, we got a lot of seats up front, so those of you that are standing in the back, please feel free to just come up here and find something. Anyway, I'd like to just say thank you very much for coming and being part of this event. And we're really excited to have Paul back as our keynote speaker. Paul, as you may or may not know, claims Colorado to be sort of partially his home. He's born and raised here for much of his life. And we always like for him to come back and share his wealth of knowledge. So please put your hands together for J. Paul Reed.
Yeah. Good morning. How's everyone doing? All caffeinated? So some of you that may have been looking at the schedule may have realized this is in the schedule as Keynote. And it was funny, somebody tweeted at me, just realized that J. Paul Reed's going to be here, so amped. And I was like, me too, I'm amped as well. And then somebody was like, wait, you're amped, or you just realized that you're going to be here at DevOpsDays? And I was kind of like, both. I mean, you're not wrong, right? So that's why this is listed in the schedule as Keynote. And Jason did steal a little bit of my thunder. I did grow up just up the road in Fort Collins. And I always feel like it's a privilege to come back and be with this community. I kind of feel like this is my home DevOps day. So I'm always stoked to be here. I'm based in San Francisco, and I get to see a lot of different tech communities. And so when I look at places like Minneapolis, Austin, Portland, Dallas, Seattle, and even Silicon Valley, I just want to note that the Denver, Boulder, and Front Range tech community is second to none of these. And I want you all to give yourselves a round of applause for being here, having events like this, being a part of this community, because this is an amazing community. So go ahead, give yourselves a round of applause. It's events like this that build that community. And Denver and Colorado Tech is amazing. So I'm glad to be here. So, Keynote, what are we actually going to be talking about today? Whispers in chaos. Well, chaos, what are we talking about when we say chaos? Well, I'm talking about incidents. So I want to start with a little survey. And keep your hands up for this survey. Raise your hands if you're an SRE or in operations and you work incidents. Okay, keep them up. Raise your hands if you're a developer that gets pulled into working incidents. Okay? And raise your hand if you see the people with all their hands up working incidents and just want to know when the website's going to be back up. Okay, that's pretty much most of the room. So I think we're going to have an interesting discussion here. So I have a question for all of you. How do you know that an incident is occurring? How do you know that an incident is occurring? Vicarious, I like that. Monitoring, that's how you know. By the way, it's not a trick question. I hear somebody back like, Kubernetes, that's how you know an incident is occurring. No, it's just monitoring. But an interesting riff off of that question is, all right, once you know an incident is occurring, how do you know what to do when an incident is occurring? How do we deal with the chaos of incidents? And how can we get better at dealing with this chaos and incidents? So that's what we're going to be talking about today. So this is the required About Me slide. I'm not going to go through it. I'm going to point out two things, though. I'm J. Paul Reed on Twitter, so if I say something and you're like, that's crazy or that's interesting, you can tweet me. That's totally cool. The other thing I'll note is I just finished up my Master's of Science in Human Factors and System Safety, and I think that's important because a lot of the things that we're going to be talking about today actually have to do with human factors and system safety. It has a really interesting overlap to operations and the work that we do in technology. So back to this question, how do you know what to do when an incident is occurring? Well, so the first part to answering this is to look at how humans react to problems and how our brains sort of interpret problems. So when studying the brain, one of the things that researchers found is there's really what they call two brain systems. They had a very interesting title for them, System 1. System 1 is automatic and quick. It doesn't take much effort. There's no sense of sort of voluntary control when we talk about System 1. And then there's System 2, which they describe as effortful. It's used for complex computations. And I actually really like this last definition, associated with subjective experience of agency, choice, and concentration. So when we say that we're concentrating or we feel like we're making a decision, that's System 2. Now this comes from research by Daniel Kahneman, who was a psychologist. He actually won the Nobel Prize in economics. And a lot of the psychology that he studied had to do with how humans, we think of economics as a very rational discipline, but he was a psychologist and he looked at how humans make decisions that might not entirely be rational in economic contexts. So that was kind of interesting. He won the Nobel Prize in 2002. So what are some examples of System 1, System 2? So orienting to the source of a sudden sound. Somebody were to drop a plate in this room and our heads were to turn, that's System 1, to find where that noise is coming from. Complete the phrase bread and something probably popped into your head, right? That's System 1. 2 plus 2 equals what? System 1. Interestingly, we'll come back to this. Finding a strong move in chess is System 1, but only if you're a chess master. So remember that, because we'll come back to it. It's kind of an interesting aspect to this. System 2, focusing on a particular voice in a crowded room. So this is if you're at a party, there's a lot of noise, and you're trying to listen to what the other person is saying, System 2. Counting the occurrence of the letter A in this slide, filling out a tax form, system 2. I like this, checking the validity of a complex logical argument. Requires concentration, requires our own agency to validate that argument. So that's all system 2. Now, the important part of system 2 is they require our attention, and it's disrupted. System 2 thinking is disrupted when attention is drawn away. So for instance, if I'm listening to you in a really crowded conversation, or really crowded room, I'm trying to listen to your conversation, and a waiter drops a plate, thing of plates, and we look to find that sound, system 2 thinking is actually disrupted. And that's why it may take us a second to refocus, and we might have to ask that person to repeat what they were saying. But it turns out, as things with the brain are, it's more complicated than that, so there's more research to read. So we're going to be taking a look today at some work done by John Allspaw. There are better photos of John, but I just like this photo, so I will always use this photo. It's a little grainy. But for those of you who don't know, he was the CTO of Etsy. He was a program chairperson for Velocity Conference. He now runs a consulting firm called Adaptive Capacity Labs. And he did his thesis in human factors and system safety on trade-offs under pressure, heuristics, and observations of teams resolving internet service outages. So we're going to go through some of the things that he found, see if any of this resonates with you and the work that you do. So he studied an incident at Etsy, and the incident was on December 4th, 2014, during the very busy holiday shopping season, about 1 in the early afternoon. The personalized homepage for logged-in users was experiencing slowdowns. People are having trouble logging in and seeing that page. So how many of you do timelines when you look at an incident to figure out what happened? Yeah, I see a lot of hands going up. That's great. That's one of the first things he did. This is right out of the Field Guide to Understanding Human Error. And I don't want to go through a bunch of this, but one thing I will say is that I think if you look at a lot of the timelines that we do in tech, they really just scratch the surface. There's 3 aspects to this timeline that are really important because it puts together the graphing data, and that's on the top there, puts together the tasks of what people were doing, and then along with what they were saying when they did that. And this is what allows you to make sense, or at least more sense, of incidents. When you put this data together, what you can find is there's those vertical lines, and they're listed there as T1, T2, T3. Those are what I call capital E events. And they're sort of what you might consider pivot points in the incident, where somebody realizes something, or some graph goes up at the top, and then somebody says you see it at the bottom, right? They're points that punctuate this incident that we're in. So that's sort of what John did. It turns out Etsy does most of their work via ChatOps and on IRC. So he had a bunch of data to go through. He plotted all of the requests. These are actually web requests to different services in the Etsy infrastructure. So I think my favorite one is, you'll notice up here this says staff directory access. He actually saw when people were accessing the staff directory so they could page them. He had that wealth of data, and he put it all on one timeline. And you'll notice those vertical lines, he did the same sort of event tracing. You see here where some person discovered something, and it was a pivot point in the particular incident. All right, so of course, because software is a team sport, I love the academic phrase for this, combined IRC utterances. So this is in the IRC channel where they were working the incident. All of the different engineers and people involved in the incident, each dot represents some time when they said something in the channel. So he was able to sort of correlate when were engineers doing things, saying things, when were they saying a lot of things, when were they maybe not saying a lot of things, and what does all that all mean? Now I want to bring up a couple of, I want to point out infrastructure, InfraEng 1 and InfraEng 2, because we're going to come back to those people, and for our purposes we'll just call them Alice and Bob, but we'll come back to them because it turns out that they play a particularly interesting role in this incident. So Allspaw identified 3 monitors or heuristics that engineers use to work incidents, and I want to see if any of these resonate with your own experience of working incidents. So the first one is change. What has changed since the system was in a known good state? The first thing he found that engineers asked themselves in an incident, okay, who pushed code, right? Who did a deployment? Who checked something in? But this also includes things like network changes, where there any infrastructure changes, things like that. So that's really the first thing that he found engineers ask themselves in an incident. What's changed? Heuristic number 2, if that first heuristic doesn't work, nothing obviously changed in the system, then what do engineers do? And heuristic number 2 is to go wide. And this is the idea that engineers start to widen the search of the contributing, the cause, we might call it, of the incident, although that's an interesting concept. We can talk about that later. But looking at all of the possible contributions, going from very narrow, potentially, about change to very wide. What's the universe of imagined possibilities that might have, quote unquote, caused this incident? And you'll notice, by the way, this is not just about change. It's not just who deployed what or what was committed or what infrastructure. It really is the entire universe of possibilities. And then finally, heuristic number 3 is this idea, he called it convergent searching. So this is the idea that as you are searching this universe of possibilities around what could have caused the incident, he called it going very wide and then going very deep. So when we see something in an incident, I think it might be that, engineers tend to then go very deep into investigating that particular possibility. And what he found is that they use it not just to confirm that that may be the cause, but also to disqualify that that isn't related to the incident. So we do this process of going very wide and then going very deep, and we use, the important part is the disqualification, that we actually say, I know it's not the network, or I know it's not the file server, and that allows us to potentially go back wide to other possibilities if that's not actually related to the incident that we're facing right now. This heuristic, by the way, is what allows engineers to make that switch from going very wide to very deep, and then when we say, yes, that sounds right, maybe I should investigate that more, or not, and I should go back to very wide. So he found actually 2 different examples of this heuristic. And we confirm and disqualify things by specific and past diagnosis, or, and this is interesting, a general and recent diagnosis that comes to mind by matching the signals or symptoms that we see. So what does this mean? Well, it means we either use a really, really painful incident memory. These are incidents that we keep with us throughout our entire career. We tell the stories at conferences. Or an incident that is still in what I might call your L1 cache. It's painful, it's recent. And we're going to talk a little bit about this. But notice both parts of this heuristic that we use when we're working on incidents. So back to the Etsy incident. The page load time increase was caused by CDN cache misses due to an HTTP 400 status in the API from a closed store. So Etsy has this concept of if you close down the store that you're running, the status of the store in the database is set to closed. Referenced by a blog post in the sidebar. So basically what had happened is an Etsy employee had published a blog post. That was actually the change. It wasn't a code commit. It wasn't an infrastructure change. They published a blog post. And in that blog post, had caused there was JavaScript in there to load information about their store. But their store was closed. So the result of that was not being cached, which means every single person trying to load that page, all of their customers during Christmas, kept going all the way through the system and not using the caching network, which was causing, of course, performance problems. So that was the cause of this particular incident. Now, when they looked at this is something called process tracing. So John actually mapped out, you can see the time up top, and process tracing, critical relayed observation, those are in circles, and a stated hypothesis. So critical relayed observation is somebody telling someone else, I think this is the problem. They're relaying that to other people. And then somebody else stating a hypothesis, I think those are in squares, I think the problem is X. So we're going to zoom in a little bit on infrastructure engineer 1 and 2. And what's interesting is that very early in this incident, Bob says frozen shop. I think it's a frozen shop. You'll notice there's not really any evidence for that. But very early in this incident, he said frozen shop. And the reason when Allspawn went and debriefed this engineer was because in the first 2 weeks of this engineer's work at Etsy, they had run into a frozen store problem twice. Now, they had been at Etsy for 3 or 4 years at this point, but that was so impactful to them. One of the first things I ask in an incident, is it a frozen store? And in this case, it actually turned out to be a frozen or closed store. Now, the other interesting thing is Alice down here, Infrastructure Engineer 1, brought up varnish queuing and then checked the varnish queuing to see if that was the problem. And it turned out it wasn't the problem. But the interesting thing here is the reason Alice asked this question is because Etsy had been having some problems with their varnish cluster and in the past 4 to 6 weeks. So she'd been dealing a lot with those particular problems. And that was because it was recent. That pain was still fresh in her memory about recent issues. That's the first thing she asked. Now, the fascinating thing here is when Allspot interviewed her after all of this and said, hey, do you remember that incident on December whatever where the website didn't load? Her first answer was, oh, right, that was the varnish problem, wasn't it? This was weeks after. In her memory, she had encoded it as, oh, that's the varnish problem, because at that point in time, varnish had been a big problem for Etsy. Now, we all do this. Have you ever had something where we moved network providers, or we got a new SAN in, or we switched from Oracle to Postgres, and something in the infrastructure is just not very stable, so whenever you have problems, it's like, yeah, it's probably Postgres again, or probably MongoDB, whatever it is, right? We'll go fix it. That's what's going on here. So bonus heuristic that he found, testing the fix. So quick survey about heuristic 4 before I show it to you. When you do a deployment, put your hands up. As a rule, when you do a deployment, how many of you make sure all the unit tests pass first before you do a deployment? Lots of hands going up. Very good. Cool. All right. Now, imagine if you had an outage, and in the context of that outage, you made a one-line feature flag change to a configuration, you got it reviewed, and there was a lot of pressure to deploy this fix. Now raise your hands if you'd still wait for every single unit test to pass. A lot fewer hands. Shouldn't it be the same? This is an example of us using our heuristics to say, under certain circumstances, I might make a different decision. And he found that here. He asked engineers this: would you wait for all of the automated tests to pass before you deploy changes? 1 on the left there, never. 5 on the right, always. Again, engineers, we use heuristics. By the way, I like this one engineer who says, I never wait for unit tests to pass, ever. It's like, okay, cool. You get to be on call now all the time. But the point is, we use both of these systems. We use System 1 and we use System 2. This is an example of System 1. If you've ever been in an incident review and somebody says, why'd you make that decision? You're like, I don't know. I just thought it was the right decision to make. That's System 1. But when we're doing that searching, that convergent searching and that analysis, that's System 2. So we use both in the context of an incident. Okay, next question on our exploration today. How do you get better at detecting an incident is occurring? Think about that. How do you get better at detecting an incident is occurring? You monitor things better. It's still not a trick question. Somebody in the back is, use Scala in the JVM. No. Just monitor things better. But we might ask ourselves, okay, well, what we're looking at today, how do you get better at knowing what to do when an incident is occurring? And this is a big question. We all want to be better, especially if we're on call, at resolving incidents. There's money at stake. It'd be nice to go back to sleep if it's 3 a.m. So how do we get better at this? Well, Hoffman and Klein did a bunch of research, and they came up with this concept of expertise. And they worked to sort of define what does expertise mean. And they said that experts use their knowledge base to recognize typicality. So in other words, they can look at a system, and they did a lot of work with firefighters. So they found that firefighters, when they roll up to a fire, can recognize, does this fire seem typical in my experience? Does it have the same feel to it? They can make fine discriminations. So this is if I'm doing something and it's not working, or it's having an effect that I didn't expect. I can make subtle changes in my approach to see if that gets the effect that I want. And they can use mental simulation. So what's interesting about this is firefighters can roll up to a situation. They're like, yeah, I approximately know what happened before we got here. I can see all of the ways potentially that we got to this point where we are. And then I'm also able to see all of the outcomes that are possible as well. So they're good at mentally simulating how situations are going to play themselves out. They also found that the knowledge base, this knowledge base, is used to apply higher level rules. So when we talk about people that are novice or new at a job versus people that are very experienced, the problem isn't that they don't have the ability to apply the knowledge base to get better outcomes. It's that they just don't have the knowledge base. They don't have it yet. And so they can't apply these higher level rules about when to do these things because they just don't have the well of knowledge to make those applications. And I really like this quote. With experience, a person gains the ability to visualize how a situation developed. That's the mental simulation we were talking about. And how to imagine how it's going to turn out. Experts can see what is not there. Now, this is interesting. And the example that they give is a music tutor was working with a student and was finding that the student wasn't adjusting the out-of-tune notes. And so the insight, and this was, I think, a bass instrument. So, and students will play notes out of tune all the time, but what they realized was the reason the notes were out of tune is because they weren't adjusting the note when they realized it was out of tune. And so the insight there isn't that the note was out of tune, but the expert's like, what this situation is lacking is your correction. So it's something that is missing. So how can you promote this sort of experience that builds useful experience? And there's two different ways to do that. People have heard of the 10,000 hour rule. You may have heard about it from Malcolm Gladwell. It was popularized in Outliers. And of course, people have a lot to say about Malcolm Gladwell. We'll get to that in a sec. But it is actually based on a study that was done in 1993, the role of deliberate practice in the acquisition of expert performance. So a lot of people, as I mentioned, say, yeah, Malcolm Gladwell has a tendency to put a bunch of science together with some fun stories, and I'm not sure how scientifically accurate it is. The person who wrote the original study actually was tired of having that complaint thrown at him. So he wrote a follow-up study because of Malcolm Gladwell's work, where basically it was a response to criticisms. But anyway, if you look back at the original research that was done back in the early 90s, what they were talking about is practice of about 10,000 hours over about 10 years. And the study was about things that we might think there might be some sort of genetic predisposition for. So they were looking at people that are really good at sports, really good at music, really good at chess, things like that. And what they found is that people can have gains in the practice of whatever they're doing by doing this concerted, deliberate, effortful practice over this 10,000 hours. We might call this flow. People say getting into flow. That's what they were talking about. Now, it's interesting. The systems that they studied are what they called relatively stable systems. So what that means is the rules of music don't really change that much. The rules of chess don't change. The strategy does, but the underlying rules don't. And by the way, this is why making a strong move in chess is system one, but only for chess masters, because they have been doing this for 10,000 hours. And so they can come up with those moves very quickly off the cuff. What's interesting about this, by the way, they gave the example, system one thinking is often used like if you move to a new town and you are finding different paths to get, you're trying to orient yourself and learn which roads to get to the grocery store and all of those different things. That is, takes a lot of concentration, but once you have it, it becomes system one. So this only applies to things that we can actually keep in system two, that we can get better at music, we can get better at operating large-scale distributed systems. But for instance, our brains at some point for finding things like the directions in a city that we've lived in for 20 years, at some point that switches to system one, and we lose the ability to get into flow around finding our way to the grocery store, because there's kind of only one way to do it that we found satisfies everything. So people familiar with this particular incident, this was January 15, 2009, about 135 seconds into a flight. Plane hit birds. People remember this? It was the Miracle on the Hudson. By the way, I've been told that I can't do a presentation without aviation information, so here's the requisite slide for that. But yes, people remember the Miracle on the Hudson. and the safe landing there? Well, so they looked at expertise in other systems, right? And this is one of the ones they looked at. This was Sully, Captain Sullenberger. And when they interviewed him, they found a couple of really interesting things about the way that he handled that particular flight. First thing is, he immediately started the auxiliary power unit when they hit the birds, and both engines shut down. Now, if you go look at the checklist for the Airbus A320, that's item number 15 or 20. So they asked him, well, why did you do that immediately? And he said, well, I have a lot of time in this airplane, and this airplane uses electricity to move things like the flight control surfaces. If I don't have engines producing electricity, that's going to be a problem for me. So I immediately turn on the APU so that we could have electricity to move the ailerons and the elevator and the other flight control surfaces. Taking control of the aircraft from his co-pilot. So a lot of people might think, well, okay, so he was the captain, it was some ego thing, that's why he immediately sort of took control of the aircraft, and it turns out that's not why. Captain Sullenberger had, let's see, about 20,000 hours of flight time, and he had about 4,700 hours of time in this particular aircraft. The co-pilot, this was his first flight in this type of aircraft after the check ride. Now, he had plenty of experience. He had about 15,000 hours flying experience, but in terms of in type, had just come off the checklist, or the check ride. Now, here's the thing. He made this decision because he asked the co-pilot to run the checklists, and the co-pilot had just done all of the tests on what are on the checklists. So he was uniquely suited to do that particular task. Well, Sully had more time in the airplane, was more familiar with it, and just flew the airplane. Finally, pilots, I'm a private pilot, we're always taught if you lose an engine, you try to make it back to a runway if possible. He made the decision to not attempt to land back at LaGuardia, and that turned out to be a very good decision. Saved a lot of lives, and that was also different. And again, he was a glider pilot, so he was looking at the energy in the aircraft when he made that decision. So that's expertise in aviation. This is expertise in operations. So how do we transform experience and expertise? So there are some ways we can do that. The opportunity, personal experiences. So this is the opportunity to be continually challenged. This, by the way, is how we keep things in System 2. We need tasks that keep our brains engaged on the thing that we're trying to learn. Directed experience, receiving tutoring, so to be able to tutor. We'll come back to what that means. Manufactured experiences, training, simulation, and vicarious experiences, so painful and memorable events that we craft into stories that we tell others. What does this mean in operations? Personal experience, that's what on-call's about. We're challenged usually, or hopefully, well, hopefully not, but often we're challenged in on-call, and that is personal experience. Directed experience, training, code review, pair programming, and wikis and runbooks. The point I want to make here, one of the most important benefits of code review is learning how to review code for someone else. It's not to give the feedback about the code, it's to actually mentor them so they become good code reviewers. That's where the benefit comes in building your own expertise. It's not really about the code. Chaos engineering game days, there's lots of discussions around that. We might talk about it here, maybe in an open space. And then, of course, vicarious experience. I remember this one time, one incident where it was DNS. I want to just point vicarious experience because this is a great quote from Dr. Richard Cook. Success comes from experience, but experience comes from failure. And we should remember that. All right, second way that we do this, building expertise, is exploring discretionary spaces. So Rasmussen triangle, I'm going to go through this fairly quickly. There are three boundaries of this triangle. Boundary of economic failure up on the upper right, boundary of unacceptable workload, and boundary of functional acceptable risk. So what does this mean? Economic failure means if we cross that boundary with our system, it would be too expensive, we would not do it. So it would be too costly. Boundary of unacceptable workload, that means it takes too much effort to do it. So as humans, we're somewhat inherently lazy. So, and what I mean by that is we try to get the most work done for the least amount of effort. We're always optimizing the work that we do. It's just ingrained in the way our brains work. And so if we cross that boundary, it would take too much work. And then finally, this boundary of acceptable risk, that's where the big boom happens. So we have these things called pressure gradients. Cheaper, better, faster. That's pushing away from the economic boundary. maximum work for least amount of effort. That's us pushing away from the other boundary. Where are we all pushing this system? Towards the big boom, right? Now, the point that I want to make is, in this model, there's something called the discretionary space. And when we look at Netflix and Amazon and Google and Microsoft and all these companies that do amazing things that don't seem to have as many outages we think as we might have, it's not that they don't have outages. It's that they get really good at exploring this discretionary space. Their operations teams and developers get really good at exploring this space so they can wrestle the system back across this line before it turns into that crater in the ground. So it's not that those organizations don't have incidents. It's that they have incidents that don't turn into accidents that customers can see. And that's, by the way, why you see incident response and postmortem and root cause analysis. This is out of the SRE book, the Google SRE book, by the way. That's why it's so low in the stack. Because this stuff is how you actually build the other stuff that gets those outcomes that you see with Google. So Etsy, in their debrief facilitation guide, asked just 2 questions when they run a postmortem or a retrospective. Did at least one person learn one thing that will affect how they work in the future? And did at least half of the attendees say they would attend another debrief in the future? And basically what they're trying to understand is, did you learn something that you will apply in your day-to-day work that will make the system better? And was this experience good enough? Was it healthy enough that you would come to another one? Now, raise your hand if the goal of your retrospectives are remediation items. Yeah. And that's the point here. For Etsy and other organizations that do postmortems like this, it's not about the remediation items. That's not the goal of a retrospective or a postmortem. You might wonder, well, then what is the goal of those crazy organizations that do that? This was my thesis from the same university that Allspaw got his. And it's a big, long title to make it sound fancy, but that's actually what I studied, is what do high-performing organizations, what do they use their postmortems for? What do they do in them, that sort of thing. So I'm not going to bore you with that in this talk. That could be a whole other talk, but you can grab a copy of it at the URL there if you're curious. So I started this presentation by asking, how do you get better at knowing what to do when an incident is occurring? And it turns out the answer is fairly simple. Create space and experiences to facilitate the cultivation of ourselves and our teams so as to improve our collective heuristics at detecting weak signals and ambiguity in the complex socio-technical systems we operate and in which we exist. Or, practice makes better. Doesn't make perfect, makes better. Expertise takes time and space. And to get expertise, you need to create that time and space. And lastly, you might have seen on the opening slide that I had this photo and talking about chaos. And you might have recognized this is a photo from Voyager 1. It's often called the pale blue dot photo. There's an interesting story about this. Carl Sagan and a bunch of engineers, when Voyager 1 was leaving our solar system, told a bunch of other engineers, hey, turn Voyager around. I want to get a picture of our solar system. And one of the engineers said, there's absolutely zero science in doing that. Why would you do that? And Carl Sagan went to the NASA administrator and got them to turn the camera around because he was like, it's not about the science. It's about humanity. It's about the people. And this was the picture that they took. And when they announced it, he had a great quote. He said, on that blue dot, there's where everyone you know and everyone you've heard of and every human being who has ever lived out their entire lives. And so the point that I want to make to you and ask you to do is, amid all of that chaos of incidents and learning new technologies and trying to do the DevOps, it's just us out here. Be good to each other on our shared journey to expertise. Thanks.
Okay, we're going to take some questions while we have Kim come up here and get set up. So who has a question for Paul? I'm going to throw this little box at you, but don't worry, it's soft. So anyway, we got questions for Paul? Yes, right over here.
How do you lighten the mood when everybody's very serious about incident response and wants that resolution? How do you bring people to that calm state?
You make a loud squealing noise like that, and that lightens the mood. So that's really hard, and it can be hard to do that. I find that questions like that tend to be interesting because they tell a lot about how your organization thinks about the idea and concepts of failure. I think, so I can't give you a specific answer because it's going to be different for different organizations. The one thing I can tell you is being present as a leader when those incidents are going on, which may mean, by the way, letting the team know I'm here but getting out of the way, can help at least maybe not lighten the mood, but make it like the people that are working that incident feel supported. I guarantee you, people that work incidents, there's nothing worse than working an incident and they're like, nobody cares about this. Oh, and maybe they're yelling at me. So if you can show your support in that way, it may not lighten the mood, but it makes the experience a lot better. And I think, one more question? Or are we ready to, one more? If there is one? We can also do an open space about this.
All right, one more time for J. Paul Reed. Please put your hands together.